The name of this exercise is create an operation using interpolated two-axis vectors. Estimated time to complete is 8 minutes. In this activity, you will create a variable axis surface contouring operation that uses the surface area drive method and the interpolate vector two-axis option to finish the contour surfaces. Step 1. Open MNF11 surface area 9. Open 2. Create the operation. From the ribbon, choose Home tab, insert Create Operation. In the Create Operation dialog box, set the following operation parameters: type, group, list, mill, multi-axis. In the operation subtype group, variable contour. It's already selected. In the location group, program, tool, mill, geometry, MCS, methods, mill finish. Click OK. Define the drive geometry. In the drive method group, from the method list, select surface area. It's already selected. The surface area drive method allows you to define a variable tool axis and to cut directly on the drive geometry. Click OK to close the drive method message box. There is no message. The surface area drive method dialog box is displayed. I don't think so. No, it's not displayed. In the drive method, in the drive geometry, right click in the background of the graphics window and choose rendering style wireframe with hidden edges. Rendering style wireframe with hidden edges. Wireframe, yeah, there it goes. Okay, in the drive geometry group, click specify drive geometry. The drive geometry dialog box is displayed. Select the first 4 faces to define the first row. What the? Select the first 4 faces to define the first row. Which is this one? No, this one. One, two, three, 4. Click start next row. By choosing this option, you have specified that every row will contain 4 faces. You will no longer need to choose start next row when beginning a new row. Select the 5th row. Select the 5th through By choosing this option, you have specified that every row will contain 4 faces. You will no longer need to choose start next row when beginning a new row. Select the 5th through 8 faces. Select the 5th through 8 faces. What? Click OK to complete the drive geometry selection. The surface area drive method dialog box is displayed. Define the material side and cut direction. In the drive geometry group, in the specified drive geometry row, click display. Specify display here. Okay. The default drive direction, material side, and step over direction vectors are displayed. The material side vector determines which side the tool contacts when cutting on the drive surfaces. The material side vector should point away from the part along the surface normal and toward the material to remove. If it does not, click flip material to reverse the direction. A drive direction vector, V material side vector, first cut, step over 1, 2. Okay. Refresh the graphics, refresh. Click cut direction. Cut direction defines the direction of the first cut and the quadrant where the first cut will begin. Click the vector shown. Define the step over. In the drive settings group, set the following: step over equal scallop, maximum scallop height 0.010, the step over option controls the distance between successive cut passes. Scallop height is a maximum allowable height measured normal to the drive surface. In the preview group, click display to verify the drive points and zigzag drive path are defined on the drive geometry. Refresh the graphics display. Click OK. The variable contour dialog box is displayed. Step 6. Define the interpolated tool axis. Okay. The part requires a tool axis that follows the general shape of the drive surfaces while avoiding excessive tool axis change. In the tool axis group, from the axis list, select Interpolate Vector. The Interpolate Vector dialog box is displayed. An array of tool axis vectors are displayed in the graphics window. Tool axis group, from the axis list, select Interpolate Vector. In the tool axis, from the axis, select Interpolate Vector. Okay. The Interpolate Vector dialog box is displayed. Really? I don't see it. I guess I have to go and do it myself, right? An array of tool axis vectors are displayed in the graphics window. These vectors are normal to the drive surface. You can remove, add, and edit vectors to control the tool axis. To edit or remove a vector selected in the graphic window or from the Interpolate Vector dialog box list, display interpolated vectors. refreshes the screen and updates the currently defined vectors for visual references. Right-click in the background of the practice window and choose Render Style Static Wireframe. Okay. Right-click the vector shown and notice the available option. Available options: reverse direction, use user orientation, remove, reset the default. This is a user-defined vector that you can delete or move. Click the vector to activate the dynamic manipulator. Select the origin and drag the vector to a new location. Okay. Right-click the vector and choose Show Coordinates. What the? Oops. Choose Show Coordinates. Right-click the vector and choose Show Coordinates. From where? Default display. Show Coordinates. In the Interpolate Vector dialog box, scroll through the vector list. The vector selected in the graphics window is highlighted in the vector list. Notice that the vector is classified as user. In the vector list, select vector 3. Notice that vector 3 is a system-defined vector. Okay. In the vector list, right-click vector 3 and choose reverse direction. Notice that the remove option isn't available. You cannot move or delete